by first looking at exponent laws.
Welcome everyone to my series on calculus. What I like to tell my students is that this really is the first real math course that you're gonna do. Up to this point, everything else that you've done has really been just laying the foundation or getting you prepared for the race. But now that we're here, now we're going to start running with it. Okay, and you're really going to see some powerful mathematics come out of this. In fact, there's a quote out there by a gentleman named W.B. Smith. He says that calculus is the most powerful weapon of thought yet devised by the wit of man. And I hope by the end of this series of lessons here that you have an appreciation for what he was trying to get at when he said that. To begin with, though, we do have to take a small look back. And in fact, we're going to call this pre-calculus, okay? Which is essentially my way of saying we are going to do a review, okay, a review of algebra. Let's just zoom out a little bit here. Whoops, wrong way, did it again. I'm going to review of algebra here. So what we're going to do to start off with here is I'm going to take a look at some exponent laws. And we're just going to go through some examples of some questions related to exponent laws, and then we'll move on. So the next few lessons here are going to be really just about this pre-calculus, about setting the stage for what's coming up later on in this course. A lot of algebra in calculus, very, very heavy algebra component. In fact, you're going to see in a little while here that when you work through some questions in calculus, the first step might be calculus, but then you're going to be doing all sorts of algebra to help kind of refine and make the answer pretty and easily understood there. So anyway, I'm just going to pick some questions, just some random questions that we typically use in the class here to kind of help review some of these ideas here. So to start off with, what we're going to do here is I want to simplify, okay? We're going to simplify, let's say we'll start off with, what have I got here? Try 4x to the negative, 4x to the negative 2. Okay, and we're going to multiply that by 8x to the negative 2. Okay? Now, it should be a pretty straightforward thing. Let's just think about what we're being asked to do here. First of all, order of operations tells us that we're going to have to look inside the parentheses here. Now, because we're multiplying these two together, this is not actually all that necessary that I concern myself with order of operations, because it's not going to really make that much of a difference. However, one of the most common mistakes that gets made at this level of mathematics is to do things in the wrong order. Okay? Sometimes we get so comfortable with the rules, the orders of operations, it's easy to slip into kind of habitual mistakes here. So let's just take a look at this. What does this mean, 4x to the negative 2? Well, that's a rational, remember? 4 over x squared. Again, notice that the negative 2 here is an exponent on the x. There's a power here. The 4 is the coefficient. It's not actually part of that power. The base is x, so the exponent is negative 2. The negative means that we're writing that down here, okay, in the denominator. Same thing over here. The power is the x to the negative 2. The 8 is just the coefficient. Okay, and then when we multiply, I hope this is straightforward. We're just going to multiply straight across here, so we will get 32 over x, and then x squared multiplied by x squared is going to be x to the 4th. Okay? Now, I could have done that a slightly different way. Okay? I could have come over here and said, okay, well, 4x to the negative 2, 4x to the negative 2. I multiply the coefficients together, that's 32. And then remember, when you multiply two powers that have the same base there, we just simply add the exponents. This becomes negative 2 plus negative 2, which is 32 x to the negative 4, or 32 over x to the 4th. Now, you'll notice that I'm taking it down and writing it in terms of positive exponents. Is that necessary? Is there anything actually wrong with 32x to the negative 4? Well, the answer is no. No, 32x to the negative 4, that's fine. Nothing wrong with writing it like that. This is no simpler than this. You're just going to find that sometimes people prefer it if you write it with positive exponents only. So you're just going to have to make sure that you understand what the preference of your teacher is there. Okay, let's take a look at another one, kind of related to that. B. Well, let's try 4x to the negative 2. Instead, let's subtract 8x to the negative 2. Okay? Now, same as before, there's a couple of different ways that you can interpret this. First of all, we might look at the exponents there, okay, and realize that these are they're negative here, and so we might write this in terms of its rational form. 4 over x squared minus 8 over x squared. And what we're going to get here, we've got common denominators already, so it's simply going to be 4 minus 8 over x squared. So the denominator is going to stay the same form. Minus 8 is going to be negative 4 over x squared. That's one way to do it. Or notice that we've essentially got like terms here. I've got 4x to the negative 2 minus 8x to the negative 2. Well, that's simply going to be negative 4x to the negative 2. And then again, I can write that as in its rational form, negative 4 over x squared. Okay? And hopefully that makes sense there. Now, let's take a look at a variation on that. Let's say, for example, that I had, the question was, what we'll do here in C. Let's say, for example, that it's x to the negative 2 plus x over, let's say, x minus x to the negative 2. Now, this one right here, I just want to make sure that you understand how this works here, that we don't make a really, really predictable mistake here. Oftentimes when people see this x to the negative 2, they want to bring that down. They realize, oh, it's got a negative exponent, I got to drop that across the division there. That's not true. The same thing here, this x to the negative 2, that x does not pop up to the numerator. Not the way you'd immediately think there, and people make the mistake there by doing that. Really what this should be here is 1 over x squared, but that for right now that stays in the numerator. Now, there are other ways that this could be done, but for right now I just want to focus on this way of looking at this problem, just so that you don't get sucked into a very, very simple way of making a mistake here. Yes, I am going to write that as a fraction. No, I'm not going to drop this over the division symbol. And the reason for that is this bar here, and we got to make sure that you're clear on this. That bar, when it's present in an expression here, implies a set of brackets around the numerator and the denominator. Okay? It is implied. Okay? And that means there's an implied order of operations here. I have to do what's inside the parentheses first. Okay? So what that means is I need to do this addition between those two terms first, and because this is the x to the negative 2 implies a rational expression, there's my rational plus my x there. I have to do that before I can do the division. It's an order of operations issue. So now, in my numerator, okay, I look at those two right there. I've got 1 over x squared plus x. Okay, that is going to be the same as 1 over x squared plus x cubed over x squared. Then I do the same thing to the denominator. This becomes x cubed over x squared minus 1 over x squared. And so now I've got 1 plus x cubed over x squared divided by x cubed minus 1 over x squared. Whoops. Right off the screen there. Now I'm doing division. I'm dividing fractions. Okay, I've got fraction divided by fraction. Okay, let's maybe zoom in a little bit here. Okay, so bear in mind, all I've done in this next step here is I've just put together the numerators here, all over x squared. So 1 plus x cubed down here, x cubed minus 1. And so this is going to end up being 1 plus x cubed over x squared multiplied by the reciprocal of that denominator, which will make this x squared over x cubed minus 1. X squared and the x squared, whoops, sorry, that's off the screen again. X squared and x squared, I'm going to cancel. I'm not 100% thrilled with that. I'll explain this in just a second here. So I've got 1 plus x cubed. The x squareds cancel. I've got x cubed minus 1 here. Now, I'm not entirely thrilled with the idea of canceling the x cubes. Here's the problem that I run into. This expression right here and this expression are equivalent. Okay? They're equivalent. They're not exactly the same. This expression is not equal to this one. Okay, so this is a nice thing to talk about right now. They're not exactly the same. The reason for that is this expression right here, that expression on the screen right here, this has got a couple of non-permissibles. X can't be equal to 0. X cannot be equal to 1. Okay, those are two non-permissibles, and they're clearly present in this expression of the problem. Okay, now down here though, what's the non-permissible here? Well, it's just 1. The only non-permissible here is 1. So these are not the same expression. So canceling actually did change this a little bit. In order for me to make this equal, if I want to make these things equal to each other, I simply have to add the restriction here that x cannot be equal to 0. Now they're the same. Okay, now these two expressions are exactly the same. Now you might want to include here that x can also not equal 1. However, this is not exactly necessary. I mean, I can see right here that x can't be equal to 1. What I can't see is that x can't be equal to 0. That absolutely needs to be there, or else they're not the same thing. Okay, just like in the previous questions that we did up here, I didn't really have to say that x can't be equal to 0. It should be clear from the expression that it can't be equal to 0. It's when those things become invisible, that when they disappear, that I need to state them outright. Now, I, being the person that I am, I would actually encourage my students to go one step further here. I would encourage you to make this pretty. There's something about this right now that doesn't look right. Okay? And I suspect if you're watching this, there's probably a few of you out there that know exactly what I'm talking about. That 1 plus x cubed, that doesn't look right. I would change the order of that and make that x cubed plus 1 over x cubed minus 1. And then I have to include that x cannot equal 0. Now that's, I would love to see that as an answer. It's been made pretty. Okay, and when you start making your math look pretty, it will treat you right. It will behave well for you. Okay, it's when you let stuff like this happen where it's not in standard form, where the order of the terms is a little bit off, where you make some of the relationships a little harder to see. And I love the fact that we include that x can't equal to 0. Now if you include that x can't equal 1, that's good too. Not 100% necessary, but still a good idea. Now, there's a little bit more that can be done in terms of factoring of this, but we'll talk about that in a little while here. I just wanted to get the idea specifically here about how the negative exponents work and make sure that we're working that thing through properly. Let's take a look at a couple more examples here. Okay, make sure I got some room here. Okay, question D. What have I got here? I wanted to take a look at what happens if you've got negative 2, whoops, sorry, negative 2x squared y to the 4th divided by 3y to the negative 5, all to the negative 2. Whoa. Now, again, we're talking about specifically about the exponent laws. But order of operations factors heavily into this as well here. I would prefer that people started inside the exponent, inside the parentheses here. Now that's not necessary. I could actually deal with what's going on here first. But you learned the order of operations. Let's use it and let's stick with it. So let's deal with brackets first. What's inside the brackets? Well, what's inside here is, first of all, negative 2/3. I'm not going to change that. That's about as simple as that's going to get. I've got an x squared, but I don't have anything else, so that's simply going to be x squared. Now I've got a y to the 4th over a y to the negative 5. Now, remember, that's when you've got a power divided by a power and the bases are the same. Okay, then you subtract the exponents. So I've got 4 minus negative 5. 4 minus negative 5 is going to be 9. Okay, and so there you go. So now we have simplified what's inside there. I can't do anything else. Okay, I am multiplying the x squared by the y to the 9th, but I can't move any further than that because I don't know what the values are here. That's about as good as that's going to get. So now I'm going to apply the exponent here, that negative 2. So the first thing I'm going to do here, and this is just a choice on my part here, I'm going to apply the negative. Okay, so that's going to force the reciprocal of this expression. Now, that negative there, the way I've got it written here, you'll think, well, it's going to drop down to the denominator. But the negative can kind of fit wherever it wants. A negative divided by a positive is negative. A positive divided by a negative is negative here. I think I said that right. Anyway, either way, I can leave that negative up there, and this will be 2x squared y squared. And now that square applies to every factor inside here. Now, it distributes through to all of these things because there's no addition or subtraction here. Bear in mind, this is not subtraction, that's a negative sign. There's nothing in front here to make this a subtraction. This is just a negative sign here. So that square is going to distribute to all of the factors there. So negative 3 squared is going to become 9. 2 squared is 4. X squared squared will be x to the 4th. Y, whoops, wow, I forgot, I didn't pull down the 9 there. Wow. Sorry. This is a lot easier when there's students in the room to scream at me when I get things wrong here. Y, the 9 there is going to become y to the 18. Okay? So hopefully that makes sense there what we did, just the order of operations. If you're really strict with the order of operations, you should be fine here. Let's take a look at one last question here. Let's say, for example, sorry, what letter was that? A, B, C, D, this is E. Okay, here's another one. Let's say we've got 3 to the 3x multiplied by 9 to the 3x minus 2, 81 to the x all over, 27 to the x plus 2, root 3. Okay, there's a fair bit going on here, and I want you to simplify this, just like we've been doing with all of these things here. Now, this is a skill that you should have practiced back in one of your previous courses here, but again, we're pulling out these old skills because they're important. The first thing I would do here is notice that in all of these factors here in this expression, the bases of all of these powers are essentially powers themselves of 3. So this is like this is 3 to the 3x. There's nothing really I can do there to change that. But that 9, that's going to become 3 squared to the 3x minus 2. Over here, 81 is 3 to the 4, all to the x there. Divided by 27 is 3 cubed to the x plus 2. And the square root of 3 is simply going to be 3 to the 1/2. Now, do I need to put the parentheses there? Well, look, the more comfortable you are with this, the more you can do, the more quickly you can move through this. Okay? But if you're not about to, in this very same step here, multiply these things through, then no, you need to put those parentheses there or else you're going to get it wrong. Okay? Let me show you the mistake that gets made if you're not doing this correctly here. So 3 to the 3x, bear in mind what I got to do here is order of operations. I have to deal with the exponents first. Okay? And so I have to deal with this power of a power. So this is 3 squared to the 3x minus 2. This is going to become 3 to, well, to the what? Well, when you have a power of a power, you have to multiply the exponents. But the 2 is not just multiplied by the 3x here. The 2 is multiplied by the 3x minus 2. That gets you 6x minus 4. That 2 has to distribute to both of those terms in that binomial exponent. Please make sure you do that. If you don't put the parentheses there, you're creating the opportunity to forget that. Now over here in this last one, this is not usually so hard to forget here, just 3 to the 4x, that's kind of straightforward. Down here though, we run into a similar problem. The exponent on that 3 there has to distribute to both terms of that binomial exponent there. So it becomes 3 to the 3x plus 6. And then multiplied by 3 to the 1/2. We'll deal with that in just a second here. Now, I got a bunch of stuff going on here. But I'm kind of lazy, essentially lazy here. I'm going to do this all in one step here. Notice that I've got a whole bunch of powers multiplied and divided together. All of the bases are 3, so my base here is going to be 3. Now, when I multiply powers together, I add exponents. This is going to become 3 to the 3x plus 6x minus 4 plus 4x. Now, I am dividing this, although, by these two powers. So I'm dividing by this power first. Remember, I'm going to do this in order, left to right. So I'm going to divide by this power, which means subtracting that whole exponent. So subtracting 3x plus 6. Then I'm going to divide by the 3 to the 1/2. So subtract 1/2. And now we just put this all together. This is going to be 3x plus 6x is 9x, plus 4x is going to be 13x, minus 3x, sorry, did I say 14 there? Let me do this again here. 3x plus 6x is 9x, plus 4x is 13x, minus 3x is going to be 10x. Then I've got negative 4 minus 6. Okay, well, negative 4 minus 6 is going to be negative 10, minus 1/2. Now, you might be tempted to put negative 10.5 there, which is fine. It might be easier to say negative 21 divided by 2, though. That kind of looks better. Those fractions always kind of strike me as looking better than the decimals there. Anyway, we just wanted to do a little bit of practice with simplifying exponent laws and fractions like that. Okay, hopefully that gives you a little bit of help here. Now we're going to take a look at a slightly different topic.